This video is on the central nervous system, part 4. In the last video, we were talking about the things that protect the brain. So remember that the brain, a living brain, has the consistency of cold, wet oatmeal, and it is very, very vulnerable. So the first thing that we said protects the brain is the skin, then we have the skull, and then we have the meninges. There are 3 meninges. The outermost layer is called the dura mater. Deep to that is the arachnoid layer or arachnoid mater, and deep to that is the pia mater. So if we look at the arachnoid mater, this is the middle layer, and coming down from it are these little web-like extensions, which are very hard to see in the dissected sheep brain, and they're also not shown on a lot of figures. So if this was the arachnoid mater, then underneath it is this space, which is called the subarachnoid space. And you'll see these little web-like structures hanging down, which is why they call it the arachnoid being a spider, kind of building a spider web. And it's through here that the cerebrospinal fluid flows. Now, under this, of course, is going to be the pia mater, which covers the surface of the brain. Pia means gentle in Latin, so this layer is clear, it is very thin, and it covers the surface of the brain. In it are tiny blood vessels, so when you look at the dissected sheep brain, you will see the pia mater with the little blood vessels running through it. Now what's running through the arachnoid mater is the cerebrospinal fluid, or CSF. And this also is protecting the brain because it forms a watery cushion around the brain. It is very similar in composition to blood plasma, and it's formed by this organ called the choroid plexus. And there's one of these in each of the ventricles. So in the CSF, there are nutrients, there are gases that flow throughout there, and other things to help the brain. If we take a look at this figure on the left here, you'll see this is an anterior view of the brain, and everything in blue are actually the ventricles. So here we can see the 2 lateral ventricles, lateral. They look kind of like ram's horns, so you can think of them as 1 and 2, and then the CSF flows through something called the interventricular. Now remember, the word inter means between. So and foramen means opening. So this is essentially an opening between the lateral ventricles and the third. So it goes from the, again, lateral ventricles through the interventricular foramen and into the third ventricle. From there, the CSF travels through the cerebral aqueduct to the 4th ventricle. Now you'll notice the 4th ventricle looks fairly sizable. And keep that in mind when we look at a lateral view, because there it looks very small. From here, the CSF can go through the central canal, or it has another choice to go through the subarachnoid space, but I'll show you that on the next slide. So here is a lateral view of the brain covered by the meninges. Now there's no skull here. So you'll notice a couple of things. If we look at the very outermost part, we have the dura mater. But there are actually 2 layers of dura mater. There's the periosteal dura mater, which of course is attached to the periosteum on the bone. And then there is the meningeal dura mater in gray here, which is closer to the meninges. Between them, at least on the on the superior part of the brain, you have a sinus. So they call this the superior sagittal sinus. Now you'll notice again, it doesn't go all the way around. It is more on the superior part. And this darker blue is actually not CSF, but this is linked to your venous system, to venous blood. Now, so we've got the 2, again, layers of the dura mater, and they are colored kind of gray. And then deep to that, this purple layer is the arachnoid mater. Now remember, the arachnoid mater underneath it has the subarachnoid space. And this is where you see the little spider webs kind of coming down from the arachnoid mater. And the CSF is shown in a lighter blue here. So the CFS flows through the subarachnoid, underneath the arachnoid space. And then covering the surface of the brain, it's not visible, but we would have the pia mater. Okay, so again, they're not showing it in this picture, but the pia mater is going to cover the surface of the brain. So let's kind of take a look at where the CSF is formed and also its pathway. Now you'll notice here we have the lateral ventricle, one of the lateral ventricles. Here's the corpus callosum. And these red things are actually choroid plexuses. So you've got one choroid plexus in the lateral ventricle. Here's another choroid plexus in the third ventricle. Here's another choroid plexus in the fourth ventricle. So if we follow the pathway, we would say we have the first pathway would be through the lateral ventricle. So let's just start there. So number one is lateral ventricle. From here, the CSF, here it is going to go through this opening, the interventricular foramen, into the third ventricle. So number two here is third ventricle. Now from here, it is going to go through this structure called the cerebral aqueduct into the fourth ventricle. And from the fourth ventricle, it has two choices. It can go through the central canal, so I'm going to call this 5A. It can go through the central canal, which runs through the center of the spinal cord. Or it can exit right here through this aperture into the subarachnoid space where it circulates around the brain. So either central canal, which would be 5A, or up here I'm going to say 5B, the subarachnoid space. So this fluid basically is going to, circulate around your brain, delivering oxygen and nutrients or around the spinal cord, picking up waste, but eventually it's going to be used up and you want to get rid of it. And so at that point, it's going to exit through this thing called the arachnoid villus, which is then going to go through this sinus. Okay, so on its way out, it will go through the arachnoid villus and then eventually into the venous system, right? So here it's calling it the superior sagittal sinus, but essentially this is the venous system. So I'm going to say number 7. Okay, so this is a good thing to know for like the final exam, the flow of cerebral spinal fluid through your brain. This is just an MRI of a child, and in an MRI, empty places appear dark. So you can notice that right here, would be the lateral ventricle, and then in this area we've got the third, and then down here through the cerebral aqueduct to the fourth, and then you can see through the central canal here. Okay, the last thing that protects your brain is called the blood-brain barrier. And this is made of capillaries that are amongst the least permeable. So keep in mind that capillaries tend to be very permeable. These are not. And the reason is they have tight junctions. That's one reason. So remember that tight junctions basically consist of these proteins that staple adjacent plasma membranes together, preventing harmful substances from getting through, at least most harmful substances. These capillaries also have receptors and transport mechanisms and things like that. So a lot of things cannot get through, a lot of harmful chemicals, but some can get through. So fat and fat-soluble molecules can get through the blood-brain barrier. Carbon dioxide and oxygen. Alcohol, which is not a good thing. Nicotine, again, not a good thing that this can get through the blood-brain barrier, and anesthesia, which is a good thing. So I'm just going to finish this up with some traumatic brain injuries now that we know so much about the brain. And the first would be a concussion. So concussion is when you hit your head, there's slight brain injury, but it is not permanent. Sometimes when people have concussions, they are told to stay awake just to make sure it's not more serious. You can get nausea and headaches from concussions. A contusion is when the blow has a little bit more force to it and there is destruction of the nervous tissue and it does not regenerate. And cerebral edema is swelling, basically. When the brain swells it can be from an allergic reaction, it can be from physical trauma, it can be from chemicals. In any event, the brain really doesn't have anywhere to go because it's surrounded by this inflexible skull. So this can be quite serious because remember that the brain tissue is like cold, wet oatmeal. So when it hits a wall of bone, it is going to get compressed and damaged. And once the neurons are destroyed, they cannot be regenerated. Lastly, there's something called cerebrovascular accident, or CVA, or more commonly called a stroke. A stroke is, what happens in a stroke is there is an area of the brain that does not get oxygen. It does not get its blood supply. And this can be because the artery going to that area ruptured, or it can be that it's blocked because of atherosclerosis. But in any event, that part of the brain that was getting that oxygen and nutrients no longer does, and it eventually dies. So whatever that part of the brain was doing, you can lose that function. For example, if someone had a stroke and they could not physically speak, but they knew what they wanted to say, what part of the cerebral cortex would be damaged? So they can't physically speak, they can make noises, but no words, but they know what they want to say. And that would be the Broca's area. Or let's say that somebody damaged part of their cerebral cortex from a stroke, and they can see you, but they don't know who you are. Well, that would be the visual association area. So it's really helpful to understand what part of the brain is damaged with a stroke, so you can kind of empathize with the patient about what they're experiencing.